Welcome to Lesson 2, Factoring a Difference of Squares. Our objectives are to identify quadratics and binomials that have a difference of perfect squares. If we find that, we can use a special formula called the sum and difference formula to quickly factor these. Down below here, this x squared minus y squared shows an example of a difference of perfect squares. Notice I said difference, which means subtraction. And this is equal to the sum and distance formula, or sum and difference formula, sorry, which we'll go into shortly. So here's an example of quadratics with a difference of squares. Notice that there's only two terms here. So these are in fact actually binomials, but they're also quadratics because remember that quadratics have a degree of 2. No higher and no lower. They have to have exactly a degree of 2. It doesn't matter if they have an x term or even if they have a constant term. As long as there is a variable that has a degree of 2, it's considered a quadratic. Now, if you'll notice in this first quadratic, I know that this is a difference of squares because 4, if you take the square root of 4, you can get a whole number 2. You can also take the square root of x squared and just get x. And you can take the square root of 25 and just get 5. So in all these, if you'll notice that commonality, 9 is a perfect square. Obviously, we already said x squared is a perfect square, and 36 is a perfect square. Same thing over here, we just have x squared. We have 16, the square root of that is 4. In this one, 49, the square root of 49 is 7, and the square root of 4 is 2. So all 4 of these, both the far left term and the far right term, you can take the square root of and get a whole number. Or your variable is raised to an even power because taking the square root of that means you just cut it in half. So these are examples of quadratics with a difference of squares. Down below are some additional examples of binomials, not necessarily quadratics, that also have a difference of squares. Notice in this first one, we actually have two variables. We have an x squared and a y squared. But again, we can take the square root of both of those. And we already know 16 is a perfect square. In this far right one, remember what I said. If a variable is raised to an even power, then it's a perfect square because all you have to do is cut it in half. So the square root of x to the 4th is x squared. And the square root of y to the 6th is y to the 3rd. And we know for sure that 100 is a perfect square. So these are some examples of quadratics that are also binomials and binomials that have a difference of squares. So let's look at how we do this. Here's the sum and difference formula. If we want to factor the binomials using the sum and difference formula, all we do is we take the square root of the first term. So let's write that out. We would take the square root of a squared, which is a. We would then take the square root of the second term, the square root of b squared, which you are knowing is b, and we just put those into a sum and difference. So this is the product of the sum and difference. We have a minus b times a plus b, and that's simply how we factor these. Now let's try a few. So here we want to factor these quadratics using the sum and difference formula. So let's do a couple together and then you can pause the tape and try a couple on your own. So an easy way to do this, again, is just to take the square root of each term. So if we take the square root of x squared, anytime we take the square root of a variable, as I said, you just cut it in half and that's the square root. If we take the square root of 16, and if you need to use a calculator, that's fine. You can also use a calculator to determine if it's a perfect square. We get a whole number 4. So using our sum and difference formula, remember that it's a sum, which is plus, and a difference, which is minus. We have two sets of parentheses always being multiplied together. One is going to be a sum, and one is going to be a difference. And it's just the sum of your a term plus your b term, and the difference of your a term minus your b term. So we just plug in the x and the 4 and the x again and the 4 again. Okay, let's do the bottom one. So we have a little bit more here. We're going to take the square root of 4x squared. So we look at those individually. The square root of 4 is 2, and the square root of x squared, we know, is x. Now we'll take the square root of 25. The square root of 25 is just 5. Once we have these two terms, we're ready to put those into our sum and difference formula. So again, we have a sum, we have a difference, and we just pull these two terms in. So we have 2x plus 5 and 2x minus 5. Make sure you always keep them in the same order, and remember that this is a difference of squares. So if this was x squared plus 16, it wouldn't work. Or if this was 4x squared plus 25, it wouldn't work either. Now if you want to test to see whether or not this is actually correct, what we've done, all you have to do is distribute and multiply. And we should get the same equation we started with. So if we're going to distribute, and we'll test one of these, we would take this first x times each of these terms. So we do x times x and x times negative 4. And then we would do the 4 times each of the terms. So we would do 4 times x and 4 times negative 4. So let's do that. X times x would give us x squared. X times negative 4 gives us negative 4x. Now let's move on to the 4. So we have 4 times x, which is a positive 4x. And then we have 4 times negative 4, which is negative 16. So look what happens here in the middle. The negative 4 and the positive 4, those cancel each other out, so they are gone. And our final answer we would be left with is the x squared minus the 16, which is exactly what we started with. So that's one way you can test, is you can just distribute and see if you get your original equation. Okay, now let's you go ahead and try the next two quadratics and see if you can get the right answer. So pause this tape and go ahead and try to factor these using the sum and difference formula. Okay, so hopefully what you have done is you've taken the square root of 9x squared and you've come up with 3x. You've then taken the square root of 36 and come up with 6. Putting those into the sum and difference formula, we would get 3x plus 6 and 3x minus 6. You can see how nice this is. This is much easier than factoring by grouping. So in our second equation here, the square root of 49x squared is 7x, and the square root of 81 is 9. And we're ready to put those in the sum and difference formula. So we get 7x plus 9 and 7x minus 9. Okay, let's move on to our final slide. This is a challenge slide for you. So I would go ahead and try this on your own as well and see how you do, and then come back. All right, so hopefully you have taken the square root of x squared. That's familiar to you, and you get x. And then you've taken the square root of 16y squared, and it's not that much different. The square root of 16 is 4, and the square root of y squared is just y. Putting that into the sum and difference formula, we would get x plus 4y, and then we would get x minus 4y. Great, we're almost done. So in our last one, you would take the square root of 9x to the 4th. Well, we know the square root of 9 is 3, and then remember what I said. If you have a variable to an even power, it's a perfect square. All you have to do is cut it in half. So we would then have x squared. In the second term, we have 100 y to the 6th. The square root of 100 is 10. And then if we cut y to the 6th power in half, we would get y to the 3rd. Putting those into our sum and difference formula, we would get 3x squared plus 10y to the 3rd. And then we would have 3x squared minus 10y to the 3rd. So hopefully after all this, you feel very comfortable using the sum and difference formula when you have the difference of squares. Remember, a couple key terms, or a couple key items, I should say, to remember is that it must be a difference and that you must double check to make sure that you can take the square root of each term. If you cannot take the square root of each term and have it be a whole number, then you do not have a difference of squares. All right, and that concludes our lesson for today.